Good day, everyone. So this moment, we are going to discuss about systems of linear equations or solving systems of linear equations using Gauss-Jordan elimination. Of course, we have to start with two variables in finding for the solutions. And of course, let's have this first example. We have your x plus y is equal to 3. And we have the second equation is 3x minus 2y is equal to 4. So these are the two equations we are going to find for its solutions. Okay, so of course, before that, we present the identity matrix in order for us to solve for this one. So since this is a two variable or two variables, we're gonna use this one. So 1, 0, and 0, 1. So we will place the coefficients here represented by small letter c. Now, first and foremost, we will get the coefficients of each equations and place it in a matrix form. Then for the coefficients of the first equation is 1, 1, and 3. And the coefficients of the second equations are 3, negative 2, and 4. Now, we will, of course, transform this matrix into this matrix so that we can solve for the values of x and y as a solution of the given equations. So, of course, we start with, may I remind you that this is our row 1 and this is our row 2. So, these are the two rows that we are going to use in operating the systems of equations. So, first, we transform this second row into this form 0, 1. So how are we going to do that? Of course, let's use the elementary row operations. So we manipulate R1 and R2. In order for 3 to become 0, what we're going to do to R1, so we multiply negative 3 to R1, then we add your R2. Then negative 3 times 1 is negative 3 plus 3, that is equal to 0. Then negative 3 times 1 is negative 3 minus 2 is equal to negative 5. Negative 3 times 3 is negative 9 plus 4 is equal to negative 5. Then we copy the first row, that is 1, 1, and 3. After which, we will transform the y column of this one to 1. What are we going to do? We multiply 1/5 to negative 1/5 to R2. So we multiply negative 1/5 to R2. Then we copy the first column or the first row, I should say. 1, 1, then 3. Then negative 1/5 of 0, that is 0. Negative 1/5 of negative 5, that's equal to 1. And then we do have negative 1/5 of negative 5 is equal to 1. Now, as you observe, the second row already is the same with its identity matrix. Now, kung titingnan na lang natin is yung first row na lang, 1, 0 itong identity niya. Dapat gawin nating 0 itong first row, the y column. So, what we're going to do is we manipulate again using the elementary row operation. So, mangyayari dyan is, of course, we multiply, we will manipulate R1 plus negative of R2. Then, ano mangyayari? So, R1, we copy the second row, 0, 1, 1. Then, R1 minus R2 is R1 pa rin kasi 1 siya. 1 plus 0, 1 minus 0 is equal to 1. Then, 1 minus 1, then that's equal to 0. And we have your R2, the coefficient, I should say, 3 minus 1, that is equal to 2. Therefore, this is your x column and this is your y column. Therefore, the value x times 1, that is equal to x, and then y times 0 is equal to 0. Kaya x na lang naiwan, then the value of x is equal to 2. Then for the second row, x times 0 is 0. Then y times 1 is y. Then the value of y then is equal to 1. We say then that the solution of the given systems of equations x plus y is equal to 3 and 3x minus 2y is equal to 4 is 2 and 1. And of course, these solutions solution set would satisfy the given equation. Example is for the proof is x plus y is equal to 3. What's the value of x? 2. Y is 1. Then we add, then both sides. Therefore, x plus y is equal to 3 has a solution of 2 and 1. If we also deal with 3x minus 2y is equal to 4, then what's the value of x? That's 2. What's our y? That's 1. Then 3 times 2 is 6. Negative 2 times 1 is 2. Then 6 minus 2 is equal to 4. Therefore, we say that 2 and 1 is the solution of the equation 3x minus 2y is equal to 4.